Lewis dot structure explains most of the things about the atoms, the molecules. How many types of bonds can be present between the molecules, how the bond formation will take place, how atoms donate their electron, how they share their electron. He explains us about the bond parameters, bond length, bond angle, and bond enthalpy, bond order. So many things was explained by Lewis dot structure, but he was failed to explain that why molecules attain a shape, how molecules attain a shape, why there is an angle, which is bond angle, which is present between the bonds around the central atom, why this thing takes place. So this theory was further explained by the scientists Sidgwick and Powell in 1940, and it was improved by Nelom and Gillespie in 1957. So Lewis dot structure was discarded by these scientists. They just said that it was not only the simple thing that how elements uh, attain a shape, attain a structure so that they become stable. There is a proper thing, there is a proper concept which is related behind this, right? So these things were explained by the valency theory, which were not explained by uh, Lewis dot structure. Okay, so valency shell repulsion theory, Vesper theory, this was the theory which put forward to explain the shapes of the molecules. Okay, and these are known as valency shells. So electron pair repulsion theory was properly explains how the elements repel each other whenever they just attach with the central atom. Okay, for example, this carbon is the central atom and these are the attached species. So how which what is the thing which just led to the repulsion, what is the reason behind it, why these three attain this position around the central atom. So there is a proper reason behind it, which is the electron pair surrounded the central atom repel one another and move so far apart from another that there is no further repulsion between them. So because these are the same type of species, they have same type of similar compound, and we know these things same poles repel each other. So that is why they just push each other, they just repel each other and attain a state, a position where they feel minimum repulsion and maximum stability, which ultimately led to the shape of the element, shape of the molecule. Right. So these species just repel each other and take a position around the central atom where they experience the minimum energy and maximum stability. Right. So if we talk about the water molecule, so we have three types of atoms there, two hydrogen and one oxygen. Right. So this actually depend on lone pair and bone pair. So the shape of the elements depend on two types of pairs. These are bone pairs. Bone pairs means the pairs of electron which take part in bone formation, and lone pair means the electron which left behind in the valency shell without forming a bond. So if we talk about the linear symmetry where the number of electron pairs are two, okay, and out of among all these three two electron pairs all are bond pairs. So what will happen, this this molecule, this atom and this atoms experience a repulsive force with each other. So that is why they attain a state, they attain a position around the central atom where they can feel minimum repulsion and maximum stability. So this they that is why 180-degree angle is found in the linear shape molecule. So this can be found in BF2, BeCl2, HCl2. So if we talk about the second, where total number of electron pair is 3. So that is triangular planar. Triangular planar means at this time the molecules, the species attain a position where it can feel minimum repulsion and shape will be triangular planar. And second one is V, bend type of shape, that is SO2 or H2O. We have just learned about H2O. H2O is V shape. So this is V shape. This is lone pair of electron. The dotted thing Loose dot structure explains in detail about these dots. So these dots explains us about the lone pair of electrons, and these bonds, this is the bond pair of electrons. Okay, so there is a repulsion, that is why lone pair. So there is a repulsion between bone pair and lone pair, right? So whenever we'll talk about the repulsive force which exists between bone pair and lone pair, so there is a difference. There is a repulsive force between two also, means there is a maximum repulsion in lone pair. Then second, on second state, they have less repulsion between bond pair and lone pair, and minimum repulsion in bond pair and bond pair, right? So this led to the V shape. If we talk about the tetrahedral shape, where electron are four, and in case of all four bonded, we have tetrahedral, and example are NH4 positive, and second shape is triangular bipyramidal, where we have one lone pair electron, so it is PCl3. It's like, it seems like a pyramid, so that is why this is known as pyramidal. I think you are familiar with the pyramid shape. In Egypt or in movies, we have seen the pyramids. They are, the three corners are there, which are present at different angles. Okay, and take up pyramid shape. So this is known as triangular pyramidal shape. That is triangular bipyramidal. Whenever the two pyramids are above each other, it's an example. So whenever five electrons are there, all are bonding. So they'll choose triangular bipyramidal, and whenever four bonded and one lone pair electron is there, bond pair, one lone pair is there, then the structure will be seesaw at this time. For example is SF6, means fluorine surround this thing. So there you can see this thing, this lone pair shows maximum repulsion on fluorine as compared to these bone pairs. So that is why there is a large angle between these two fluorines, and we have less angles between all these four fluorines. So this proves that there is a maximum repulsion between lone pair, second lone pair bond pair, and third is bone pair. Okay, so if we talk about whenever the number of lone pairs increases, so this will affect the shape of the element. So if we talk about the eight electrons, five electrons which are, sorry, when we talk about the six electrons which are taking part in the bond formation, that is six are bonded bone pairs and zero is lone pair. So it's, they form SF5 form octahedral shape, right? Next is IF3 and CIF6, they shows a square pyramidal in which we have one lone pair. If we have two lone pairs and four bond pairs, the shape will be square planar. So you can see there is a big angle, bond angle, which exists between these two species, because we have lone pair here, which shows maximum repulsion towards the attached nearby attached species. So there are so many things which are related to this Vesper theory, right? So they just explain so many things. If you want to calculate the number of lone pairs, number of bond pairs, and the shape, we just predict about the shapes of the elements by this Whisper theory. Number of bond pairs is equal to the atom linked to the central of single bond. Whenever the elements combine with the another atom, so they share the electron, they form the bond. So they just affect each other. And if we talk about number of lone pair, so these are the total number of electron pair minus number of shared. If you want to find out, if you want to find out the bond pair, you just find out the bonded electron minus the total electrons participating in bond formation. If you want to find out the lone pair, then the total number of electron pairs and minus the shared pair. If you just minus or extract out the bonded pair from total electrons, you just find out the lone pairs. So the lone pairs and bond pairs together affects the shape of the element of the molecule, right? So there are so many main postulates of Esper theory. First is the shape of the molecule depend on the number of valency electron pair, bonded and non-bonding both. Okay, is the number of electron pair which surrounds the central atom. They just tells us about the shape. Means shape of the molecule depends on the electrons. Okay, both non-bonded and bonded means bond pairs and lone pairs. Okay, pairs of electron in the valency shell repel one another since their electron clouds are negatively charged. So the electrons which are present in the valency shell, they just repel each other because they have the same type of charge, that is negatively charged. Third, these pair of electrons tends to occupy such position in space that minimize repulsion and the maximize the distance between them. Means they just attain or just gain a place, a position where they just experience minimum repulsion and maximum stability. Right. The multiple bonds is treated as if a single electron pairs and two or three electron pairs of the multiple bonds are treated as single suppressed pair. Right. And this thing I have already told you that if we talk about the repulsion, which generally affect, which is the main reason for the shape is the repulsion between the entity attached entities and the electron clouds. Okay, so if we talk about the repulsion, so maximum repulsion is between lone pair, and on second if we talk about the less repulsion is between lone pair and bond pair, and if we talk about the minimum repulsion is there between bond pair and bond pair, because here the electron clouds are bonded together. Okay, these the entities which surrounds the central atom, okay, they just there is means they can have lone pairs, they can have bond pairs, so that repulsion which exists, which is existing at that time, just led to the space. Due to this, we just find out the angles. For example, in BCl2, we have 180-degree angle. Why? Because the maximum repulsion is this. This is the position at which these two entities feel minimum repulsion and maximum stability, and so on BF3, BH3. So the VSEPR theory is able to predict the perfect geometry of the large number of molecules, especially compound of p-block elements accurately. So this was quite successful to explain about the geometry of different types of molecules and the atoms which have different energies uh, accurately, okay, and in an efficient way. Um, right, so by this theory we just came to know about the shape of the molecules. Okay, that is due to the repulsion force, or that is why we have specific shapes of the molecules in nature.